This is the part 4 and final video of 4 video series. This final installment will be all about the small little details, bits and parts. First is the paddle switch. I made my inexpensive power on and off paddle switch as I couldn't find any around my area. Could have done buying it online, but I couldn't wait, so I just made one. I changed the light switch that I've shown in the beginning of the video. I got this higher amps switch, and this one I think will be much easier to install and modify according to what I want. First thing I need to do is run and fix the wire around the two sides of the cabinet and passing through the front panel where the switch will be located. I tilt the housing carriage and hold down the wire to the back panel to see how long will be the required length for the wire to allow it to dangle loosely. I use the big wire clips or ring to hook the wire on the back panel so that the wire can freely slide through the ring when the carriage is tilting. I use the smaller wire clips to firmly attach the wire on the side panel. And once I check that the wire is installed properly, I fasten the wire onto the body of the carriage housing. I use two small wire clips to firmly secure it. Then I would check it again by tilting the carriage housing. I did this a dozen times to really make sure if the wire is safely installed and not catching on any sharp corners or edges of the assembly. I am marking here the location of the power switch, making sure that it is in the level of my knee, or I mean above knee. Well, excuse my hairy legs there, I should have waxed it prior to filming. Okay, the paddle switch would be somewhere there. So this is the paddle switch. It is really simple. I used this piece of plexiglass, cut it to shape that I saw on the internet. On the side, it is gonna be like this, 2-layer plywood, and inserted the switch into the plywood like we normally see in our houses, and a plywood hinge sort of that holds the paddle. At the back, this piece is the piece of plywood in front. I cut out this part to insert the switch plate. And these are the spacers to make some room for the wires. Then I made a giant hinges, then drilled holes all the way through, and inserted 2 nails as a shaft on both ends. I painted it red just like the real thing, and stenciled power off sign. It's just a quick and dirty job just to make it look a little nicer. I am not gonna show you guys how I did the wirings. I just learned this simple wiring at work and I'm not comfortable demonstrating it to you. If you don't know how to wire it properly, if you have doubts, just don't do it please. Hire a certified electrician and let them do the job for you. Stay alive and be safe. I painted also the body of the switch to make it look better. Then I also add a stopper at the back of the paddle. It's a small block of wood so it won't slam the plastic switch with direct force and break it. These parts are not fully detailed in the plans, so I'm just gonna disassemble it to show you how I made them. And this part is just simply a big oversized washer, just for the looks or style maybe. This was supposed to be the rack and pinion for the tilting mechanism. I had a tilting crank on the front as part of the original design, but I wasn't satisfied with the result. The motion wasn't smooth enough. It needs finer tooth gears I think, and I would need to make a simple drivetrain to make it even smoother. But I don't have a bandsaw or harder and stable materials to use, and it's going to be more complicated. That's why I dropped the idea and use it as a lock instead. Okay, so here I attach a piece of plywood roughly 80 mil by 80 mil to make the panel thicker so it would hold the bushing much stronger. And I drilled a hole and epoxy glued a 30 mil stainless steel bushing inside. Alternatively, you can use a bearing for smoother rotation, and that is what I'm going to redo when I find time. I drilled a passing through hole on the shaft and inserted a pin to stop it from pushing inward and clash with the housing. I have had a hard time drilling holes on it. The stainless steel was so hard that I broke 2 drill bits already. It was a mess, I know, sorry about the sight. The tilt and the lift crank handles are just similar in size and design. Please never mind those marks. It was a mistake, but I don't want to throw away the material, so I just reuse it. I drilled these 2 holes and inserted the M12 nuts, then applied some epoxy glue. I cut this smaller circle with a little neck that's shaped like a flask to make the threaded rod handle hold stronger when inserted. Then I drive in the threaded rod all through and lock it with a washer and nut. Slide in the pipe and lock it with an end cap nut. For the tilt lock, I marked the location of the holes on the shaft and drilled through the MA threaded rod. When you turn the knob, the threaded rod will pull the pinion shaft against the side of the cabinet, clamping itself there, preventing the rack from moving. But this lock is not very strong. It's just a safety net just in case something happened wrong to one of the tilt mechanism parts like universal joint yoke, for example. This is how it is pinned. Then there is a washer. The purpose of this is to prevent the shaft from pushing all the way through, as I mentioned already, and clash with the carriage body as it tilts. As I've said, this is just a big washer. The size is just for visual purpose only, to complement the size of the lift crank wheels. There are lots of tutorial available in making star knobs. Just pick one that's easy for you, or you can just buy one. What you're seeing now is the input shaft. Inside that hole is the bearing where the input shaft passes through the tilt crank. It is fine if the shaft is too close to this corner than too close to the carriage housing. Here, this space is too tight. As I've said again, the shaft against the cabinet so that the carriage housing won't clash with the universal joint when tilted at full 45 degrees angle. Then here I added a small piece of plywood to clamp and secure the bearings that's embedded in between the piece and the cabinet. And inside, I drilled a hole halfway through with a hole saw on this piece of wood and did the same on the cabinet and embedded the bearing inside. Lastly, this is the shoulder joint of a tilt mechanism. It links the crankshaft and the carriage assembly via 2 joints, and I use long nuts to hold the shaft. The plywood blocks that you see here are just the long nut housing. There are really nothing special about it. It looks oversized, and yes, they are. To make it stronger, there's a lot of push and pull force going on in here, so I kinda exaggerated it. I did this part on the fly, so they're not in the plans as well. This block is a 3-layer plywood, same size as this part. Then these parts serve as the wooden flange. I cut it out a square to insert this piece to make the union stronger. Applied lots of glue and drive in some screws on the side. I used a 10mm drill bit. I drilled a hole all throughout, and for this block I drilled up to here and another one from this side. Then I inserted an M12 long nut. The hole size is smaller, which is intentional so that the long nut would hold tighter inside. And I applied epoxy glue to keep it secure. For the other one, I inserted the long nut up to this point, inserted the long nut for this hole on the side. This long nut is driven to the crankshaft, and when being tilted, the long nut travels through the crankshaft, pulling or pushing depending on the direction. Then it makes the carriage to tilt sideways or swing up and down. Then this block and this block are connected by this shaft. Then put washers here and lock with M12 nuts right there. You can also use bearing instead of long nuts if you want to, and I think it's much better. The M12 long nut and the M12 threaded rod doesn't fit exactly, so it has a little bit of play but not too much, and it's enough for me. I can live with that. I can say it's now done. Just a few reminders. You may need to chamfer this edge with a plane because it's touching the dust chute. That was intended so that the dust won't pass underneath, but I didn't know that the dust would actually come through the back and front opening here. There's a bit of a problem with my dust collection. The angle of the dust chute is not stiff enough, causing the dust to collect on the chute, where it was supposed to slide down to dust bags below, and so I needed to brush it off every now and then. Here's I think how it happens. When the blade is cutting through the wood like this, the sawdust shoots to the front, bottom, and back, and blocked by the tabletop, causing it to bounce back, and add to that the air that's been blown by the motor. So yeah, sawdust everywhere. I was thinking of adding a dust shield here, made out of plastic or something that's thin and easy to bend to deflect the dust, maybe slightly angled or curved. I'll play with the sizes and see which one works best. Or you can fully enclose the blade and make a curved slot opening here and hook it up on a vacuum or a dust collection system directly from the back panel. That would probably what I need to do in the near future. Now, how would you know if you build it well and safe to use? This is one of my concerns here. This is the Achilles heel of this design, the universal joint. When you make the universal joint, I would advise you to use thicker and stronger materials, especially for the yoke and the cross pin. If you have welding machine, then weld it. You can do so, or buy instead online or in a specialty hardware store. Do not use weaker materials than what I used here. Mine is tested 100 times already. If this universal joint snaps and your blade is at 45 degrees, it will tilt and slide and may cause a kickback when you're in the middle of cutting something, and that's seriously dangerous. Next, make sure that the circular saw are securely installed. With mine, I added some screws where I think it is safe. Make sure it is not moving. I cannot stress this enough, but make sure it fixed securely. The carriage should be perfectly fit in the housing and it's not moving even the slightest. And add this bridge to hold the sides of the housing. And I think that's it. The whole building process took me about 3 months, Saturdays and Sundays during the weekend. I started on late December last year and finished up by first week of March, I think. I also spent 1 hour to 2 hours every night just nibbling with small parts, though most of the time I was just staring on it just to keep myself motivated and excited. Thank you if you made it this far. This is my first time making a video of some sort. It's not as detailed as I wanted to be, but I still hope you enjoyed it or learned a thing or two. There will be more projects coming up as I try to equip my workshop with homemade machines like this. So please consider to like, subscribe, share, and leave a comment. If you have any questions regarding the build or the plans or anything that you need clarifications, leave them in the comment section below and I might reply with a video to answer you much clearer. By the way, making of the table saw fence can be seen or be watched on a separate video. Hope you'll watch it too. See you guys again, and for now, goodbye.